Aditya-L1 is an ambitious mission that India is all set to launch in barely a day's time. So far, NASA, Japanese Space Agency JAXA, and EU Space Agency ESA have carried out solar missions so far, 9 in total. Indian Space Agency would be joining the constellations to understand this solar system and its effects on planets, especially the Earth. So basically, India's first attempt this is through Aditya-L1, where they're going to understand the sun's heating mechanism. Here's all that you need to know.
Aditya means the sun, and L1 is a point between Earth and sun that offers an uninterrupted view of the closest star of our galaxy, hence the nomenclature of the latest ISRO project. Sun is the main source of energy of this solar system and holds the biggest secret of this universe. Aditya-L1 of ISRO is the first Indian attempt to study and understand the sun. Aditya will first be placed on Earth's centered orbit before embarking on a 150 million kilometer journey from Earth's sphere of influence to different viewing points around the sun. It will be placed in a cruising position at L1 between the Earth-Sun system in the halo orbit. The temperature at the surface of the sun is about 10,000 Fahrenheit or 5,600 degrees Celsius. So there's no way anything comes remotely close to its surface without burning down to unimaginable ash particles. So all sun missions are posted at different viewing points between the sun and the Earth. These are called Lagrange points. These points are used by the spacecraft to station with minimal use of fuel while they continue to study the sun from a safe distance. There are a total of 5 Lagrange or L points. Aditya would be placed at L1 that lies between Earth and the sun. Aditya-L1 will carry 7 payloads. 4 of them will carry out remote sensing of the sun and 3 others will do in situ observations. To understand changes in Earth's ecosystems, study ice mass, vegetation, biomass, sea level rise. These observations and studies will help understand the groundwater of Earth and different natural hazards like earthquakes, tsunamis, volcanic eruptions and landslides. In total, 9 solar missions have happened so far by countries like the US and the European Union to different Lagrange points of the sun. Aditya-L1 comes with the promise to open up a new galaxy of knowledge for India.
All right, now in 7 decades of space exploration, solar missions are relatively a new phenomenon. It all started in this millennium as India prepares for this maiden solar mission launch. A quick interview, or an overview rather, of why probe the sun in the first place. Have a listen.
Sun keeps the solar system together, from the biggest planet Jupiter to the smallest particles in its orbit. 4.5 billion years old Sun is a hot glowing ball of hydrogen and helium. Sun can accommodate 1.3 million Earths. From the powerful eruptions to the steady stream of charged particles, the Sun influences the nature of space throughout the solar system. Sun doesn't spin like, let's say, the Earth. Sun is made up of super hot, electrically charged gas called plasma. This plasma rotates at different speeds on different parts of the Sun. At its equator, the Sun completes 1 rotation in 25 Earth days. At its poles, the Sun rotates once on its axis every 36 Earth days. The temperature in the Sun's core is about 27 million degrees Fahrenheit, or 15 million degrees Celsius. It is so hot that it can sustain a nuclear fusion. This creates outward pressure that supports the star's gigantic mass, keeping it from collapsing. Above the Sun's surface are its thin chromosphere and the huge corona or the crown. This is where features such as solar prominences, flares and coronal mass ejections happen. Sun flares and coronal mass ejections are giant explosions of energy and particles that can reach Earth. A solar probe typically looks at studying all of these from a safe distance so that nothing gets burned down. Solar probes are also carried out to predict successfully the flares and giant explosions that propel particles from it and can cause serious damage to any spacecraft. Center and has the capability to alter atmospheres of different planets, including Earth. Sun is a relatively younger star in our galaxy. Study of the Sun helps understanding other stars in the Milky Way and galaxies beyond. The various thermal and magnetic phenomena on the Sun are of extreme nature, so the Sun provides a good natural lab to understand those phenomena. These otherwise cannot be directly studied in the lab. All these studies lead to a better understanding of Earth, its atmosphere, genesis of this solar system, and the universe.